Okay, so as I was saying, for to calculate pressure inside a liquid, this is the formula we have to use. Now, generally for a particular liquid, the rho and g, both of them are constant, right? So if you take that out from the equation, the equation will become proportional to h. Okay, so the pressure is proportional to the depth. That means if you go lower and deeper and deeper, then what will happen? The pressure will increase, and the pressure is maximum on the bottom surface. Okay. হ্যাঁ বলো আচ্ছা ক্লাস অনেক ডিস্টার্ব হচ্ছে মনে হয় আমি ভাবলাম একটু ফাস্টার যাবো বিকজ এই চ্যাপ্টারে অনেক কিছু আছে ডিসকাস করার মতো okay then we have density what is density it is expressed by rho and it is mass per unit volume okay mass divided by volume that gives us the density so we can say that mass of unit volume of an object is density of that object. Okay, of that object. So if you consider the value v as 1 meter cube, then rho will be equal to m. That means density is the mass of unit volume of any object. Okay, then it will be called density of that particular object. Then we have buoyancy. We know that whenever we actually submerge any object in any liquid, okay, we know that upward resultant force acts on it, right? So that upward resultant force is known as buoyancy. And the equation to calculate buoyancy is V rho G. Okay, now we need to know what is V, what is rho, what is G. Now V, it is volume of displaced liquid. Okay, and it is density of the liquid. Always remember density of liquid, not the object. Okay, and G is acceleration due to gravity, that you know. Now our area of interest is this one, volume of displaced liquid. This one is considered equal to volume of immersed part of the object. Okay, as buoyancy is there, definitely there is some object which has been submerged into the liquid. So the liquid will be exerting an upward resultant force that will be equal to V rho G. Now here volume is the volume of the displaced liquid. Now whenever you submerge a body inside the liquid, it will take up some space inside the liquid, right? And to give it a space, some liquid will be displaced. Okay, now how much amount of liquid will be displaced? That is equal to the volume of the object, right? Volume of the object. If you submerge the body fully, then equal volume of water will be removed. But sometimes it happens that I did not actually submerge the body fully. What happens is I have submerged it partially. Okay, so now the volume of displaced liquid will be equal to the volume of this part of the body that is immersed. That's why actually it's better to mention volume of the immersed part of the object. Okay, so volume of the displaced liquid is equal to volume of the immersed part. So whenever you are looking for the value of V, okay, just try to calculate volume of this part. Okay, that means the part that is immersed. If the full body is immersed, then you can consider the volume of the full body as the value of V here. Okay, this is very important to understand. Okay, now this is also equal to, buoyancy is also equal to weight of the displaced liquid. Now while teaching you in class, I have actually explained why buoyancy is equal to weight of the displaced liquid, or why this one can be considered as the weight of the displaced liquid. Just a short review. Okay, displaced liquid. How? If you notice V rho G. Now V into rho, this one can be replaced by mass. Okay, this is the volume of the displaced liquid. This is the density of the liquid. So this is mass of the liquid, mass of the displaced liquid into G. So m into g, that is weight, right? So whatever we are calculating here is of the displaced liquid. So it will be weight of the displaced liquid. Okay. Okay. Then we have flotation and immersion. When a body will float and when a body will immerse. Okay. There are actually two cases. Sorry, three cases. Density of object. Achha, I will just mention it, with symbol. Density of the object and the density of the liquid. Okay, there might be three cases. When the density of the object is greater than the density of the liquid, and density of the object is less than the density of the liquid, and density of the object is equal to the density of the liquid. So what will happen? If this is the case, the body will sink. The density of the object is higher, so the body will sink. The density of the liquid is higher than the object, the body will float. Okay, and now the object density and the liquid density is equal. That means the object will remain. The object will remain where left. Where it is left. Now we will try to understand these three. Okay, let us say we have some liquid over here, and I have, let us say, an object. Okay, maybe a rectangular object. Okay, I dip my hand and keep it here. Okay, now three things are possible. Number one, it might sink, that is, it will fall down. When it will happen? When the density of this object is higher than the liquid, the body will sink, the body will fall to the bottom surface, right? If the body's density is less than the density of the liquid, then what will happen? The body will float, the body will come to the top surface, okay? Now, if the density is equal, then what will happen? The body will stay where I have left it. If I had left it, in a little bit lower position, it would have stayed there. If I would have left it, in this position, like if I had left it in this position, okay, then what would have happened? The body would have stayed over there. Wherever you leave it, the body will stay over there. If the density of the object and density of the liquid equals each other, okay. So that time what happened? It will neither come down or neither it will go up. It will stay wherever it is left, okay. So whenever in the question you are asked, check whether the body will sink or float, you need to know that you need to calculate the two things. Two values you should be looking for. Number one, the density of the object. Second, density of the liquid. Then compare them and decide whether it will sink, float, or stay wherever it is. Okay. Now this case is actually important for a submarine. Okay, submarine are what? Okay, submarines are the ship that travel underwater. So we do not want the ship to sink. We do not want the ship to float. Okay, we want to stay underwater. So we have to make the submarine in such a way that the density of the submarine equals the density of the liquid or the ocean, liquid of the ocean, or we can say water, right? Okay, so if the density of the ocean liquid is equal to the density of the submarine, then what will happen? We will put the submarine in some place like this, and it will stay over there. It will not sink. It will neither sink and nor it will float. It will stay over there, right? So very important concept for creativity. Okay, so keep this in your mind. Whenever you are dealing with submarine, you need to know that you are dealing with this case. This will help you a great deal, inshallah. Okay, flotation and immersion gone. Then we have Archimedes law. Okay, we know that whenever we submerge a body in the liquid, okay, it feels lighter. I will not say it has become lighter, because the body has not actually become lighter. It just feels lighter. Okay, if I have a pitcher and it is filled with water and I'm walking, okay, it will feel heavier, right? But if I'm in the water, okay, if I put it on the water and then try to work with it, then it will become easier for me. I will feel like the pitcher has become lighter, right? So we can see that whenever an object is submerged partially or fully in a liquid, what happens? We feel like that it has lost some weight. So what is it is equal to? The the lost weight is equal to the weight of the displaced liquid. This is Archimedes law. Okay, lost weight of object is equal to weight of the displaced liquid. I hope you understand what I mean by weight of displaced liquid by now, right? Weight of displaced liquid. Whenever an object is kept in a liquid, it will displace some liquid to occupy some space. So what will happen? It will lose some weight, and that weight is equal to the weight of the displaced liquid. Okay. So that was Archimedes law. Then we have Pascal's law. Pascal's law and force multiplication, these are actually connected to each other, so I will discuss them together at once. Okay. Pascal's law says that, let us say we have, let us say we have a circular balloon, okay, and we filled it with water, with some liquid, or maybe gas, doesn't matter. It has to be a fluid. Fluid includes both liquid and gas. Anything that can flow is fluid. So liquid and gas both can flow, so both of them are liquid. So you fill it up with some liquid, then with some fluid. Then if you apply pressure, external pressure, let us say you have applied some external pressure, okay, what will happen? This pressure will be equally distributed in all the sides. Number 1 point of Pascal's law. There is no logic to consider that the pressure will be transmitted to this surface more and to the bottom surface less. There is no logic to consider that, right? Pascal's law says that the pressure will be equally transmitted in all the sides. And it will act, number 2 point, okay, number 1 point is it will be equally transmitted in all the sides, and number 2 point is that it will act perpendicular on the surface of container or on the wall of container, perpendicular to it, okay. So that is the number 2 point. Now based on this, we develop a machine that is generally known as hydraulic press. There is a thinner piston, a thinner cylinder, and the upper cylinder that is there is a more wider one. Okay, in both of them we fix 2 pistons. Okay, so we actually fill it up with liquid. Okay, so if I exert a small amount of force F1, I will get very larger amount of force F2 over here. Okay, so it doesn't have to be necessarily a piston. Let us say this is a place where we can place the object, large object, okay, heavy object. I have placed it over here. So if I apply a small amount of force, what will happen? A larger amount of force will be exerted over here, and as a result, with this small amount of force, I can actually lift it up. Now, how does the Pascal's law act over here, right? You can see that I am exerting an external pressure on this liquid, right? So we know that without getting decreased, the pressure will be equally distributed over the liquid, and it will apply a pressure on this surface, right? So which will try to actually pull it up. Okay, so the equation that we develop from this is like this one: F1 by F2 is equal to A1 by A2. Okay, so now we can see that A1 is the area of this piston, A2 is the area of this piston. Okay, now we can see that A2 is higher. Let me write the equation F2 by F1 in this way, that it will be easier for you to understand. Okay, no change, same one. So let us say A2 is 100 times of A1. Okay, A1 at 100 times of A2. So what will happen over here? F2 by F1, it will be equal to A2 is 100 A1. 100 A1 divided by A1. So A1 cancel. Then F2 will be equal to 100 into F1. That means, let us say you apply a force of 1 Newton over here. So if you apply a force of 1 Newton, 1 into 100, the force that you will get over there will be 100 Newton. So how many times is the area of the larger piston with respect to the smaller piston? That times your force will become, okay? The force you give, it will become that time, okay? If it is 100 times, then the force will become 100 times. If it is 200 times, the force will also become 200 times. So you see that we exert a smaller amount of force, but we get output a larger amount of force, right? So this is what we are discussing. This is called actually hydraulic press. Okay. And this is also called the force multiplication law. So all the necessary, what should I say, the equations I have discussed that are needed from this chapter, okay? Because in the creative, mostly you are solving C and D. Okay, you also should study A and B, go through the definition, but I don't think you will have any problem in definition. Mostly I see the students struggling with C and D, which involve mathematical analysis. So these are the important equations that you will need from this chapter. I guess Hooke's law is also there, right? Hooke's law.
Yes, sir.
Hooke's law is the last thing that we need to discuss. Okay. So before we discuss about Hooke's law, we need to know about the stress and strain. Okay, stress and strain. Now, stress is nothing but pressure. Okay, pressure and stress, they both are the same thing, same unit, same dimension, same everything. Okay. Now, what is a strain? Now, let us say we have an iron bar of R1, length L1. I have applied some force on it, some pressure has been developed in it, or we can say some stress has been developed, and as a result, the length has become L2 now. So what is the change of length? L2 minus L1. That is the amount of change, right? So the change per unit length. This is what is a strain. Okay? The amount of change that occurs in unit length, that is strain. Now, Hooke's law relates these two. The stress is proportional to the strain, or we can say the strain developed is proportional to the stress. Okay, but condition has to be maintained. The condition is within elastic limit. Within elastic limit. Now that brings us actually to another topic, that is elasticity. Now what is elasticity? Elasticity, it is a certain property of object. Okay. Now due to this property, what actually the object does? If you apply some force on it and it undergoes some deformation, upon withdrawing the force, it will come back to its original shape. Okay. The property, okay, the by virtue of elasticity, this happens. Okay. Achha. Now, if I apply a larger amount of force, still I can see that it is coming back to the original position. Now I keep on increasing the amount of force applied. Now what will happen? At some certain point, you will see that even though you are withdrawing the force, the object is not gaining back its original shape. So that time, you can say that you have actually crossed the elastic limit. Okay, so remember, within elastic limit, the Hooke's law is applicable. Above elastic limit, it will not be applicable. Okay. Achha. So stress is proportional to strain. Now we know that if I want to put an equal sign in between, I must introduce a constant, right? So that constant is known as Young's modulus. Okay. That is actually expressed as y. Young's modulus. So I think now you can do it, inshallah. Okay. Strain, this is the equation to calculate y. This value will be given mostly. And stress, that is pressure. So pressure is equal to force divided by area. So you know everything how to calculate. So you will just put the values and inshallah you will get your answer. Okay. Achha. So I have already provided you the PDF. So kindly go through it. Try to solve all the problems, and whatever doubt you face, remember to message me. Inshallah I will discuss in any of the classes with me this week. Inshallah. Okay. And tomorrow we will discuss about এক মিনিট আমরা কি ওয়ার্ক আওয়ার এনার্জি পড়ছি এখনো
আপনি দিছেন না পাওয়ার এনার্জি পিডিএফ দিছেন বাট রিভিশন করা হয়নি
স্যার আমার লাগে ওয়ার্ক আওয়ার এনার্জি থেকে
ছিল আগে ধরো আমি ভুলেই গেছি ওয়ার্ক আওয়ার এনার্জি
না স্যার ওই চ্যাপ্টারটা অনেক ইজি না, জাস্ট একটা টপিক বুঝলেই চলবে, এখনো তো বুঝতে পারবেন আপনি। আর ওই যে এফিশিয়েন্সিটা,
কোনটা এফিশিয়েন্সি?
হ্যাঁ ওইটাই সমস্যা আমাদের বেশিরভাগ।
স্যার আপনি মিউট।
Okay, so this topic I was requested to discuss, that is efficiency, output energy divided by input energy. So whenever in the question you will be said that a motor of 1 kilowatt is being used, that means a motor of 1 kilowatt means if you want to run the machine, the power that you need to supply, that is 1 kilowatt. Okay, we know that kilowatt is the unit of power. Acha, you don't need revision on the other topic like kinetic energy, potential energy. কারো লাগবে না, কারো যদি না লাগে তাহলে ওকে আমরা ওটা নিয়ে সময় নষ্ট করব না, আমরা ইয়ে করব হায়ার ম্যাথ।
স্যার আমার জন্য লাগবে না, আমি বাকিদের জন্য জানি না।
হ্যাঁ, বাকিদের কারো লাগলে ওইটা বলো, আমি সেটা জিজ্ঞেস করতে চাই।
লাগবে না,
লাগবে না, এই চ্যাপ্টার সোজা আছে মোটামুটি। ওই যে অবজেক্ট উপরে তুলবা, যে কাজ করছো সেটা বডির পোটেনশিয়াল এনার্জি ইকুয়াল। সো আশা করি পারো সবাই নাকি? ওকে, তো তাহলে পিডিএফ সলভ করো। সবচেয়ে বড় কথা ক্রিয়েটিভ প্র্যাকটিস করতে হবে। ক্রিয়েটিভ প্র্যাকটিস করবা, তারপরে মানে ইনশাআল্লাহ হয়ে যাবে আর কি। তো ওখান থেকে ডাউট গুলো আসলে ওগুলো যদি ক্লিয়ার করে ফেলতে পারো, দেন আর আটকাতে পারবে না তোমাদেরকে ইনশাআল্লাহ। আচ্ছা, তো এফিসিয়েন্সি থেকে এক্স্যাক্টলি কি জানতে চাও? আমি তো আসলে জাস্ট ফর্মুলা লিখলাম, আর স্পেসিফিক কোনো কোশ্চেন থাকলে করতে পারবো।
স্যার এরকম লাইক আমরা ফর্মুলা জানি, বাট যখন ক্রিয়েটিভে আসে তখন গুলো না সবগুলো ভ্যালু মিক্সড আপ হয়ে যায়। লাইক কোনটা কি বার করব,
আউটপুট এনার্জি কোনটা ইনপুট এনার্জি গুলো বুঝতে।
আচ্ছা, এখানে আমি যেটা বলি তোমাদেরকে, আউটপুট এনার্জি হচ্ছে মেশিনটা যতটুকু কাজ করতেছে সেখান থেকে যেটা ক্যালকুলেট করবা, দ্যাট ইজ আউটপুট এনার্জি। ঠিক আছে, আমি আবার বলি,
এনার্জি আছে, দেন পাওয়ার আছে, অনেক সময় ইফেক্টিভ পাওয়ার, ইফেক্টিভ এনার্জি, দেন ওয়ার্ক ডান, এগুলো না অনেক মিক্সড আপ হয়ে যায় যখন আমরা ক্রিয়েটিভ গুলো সলভ করতে চাই।
মানে আউটপুট পাওয়ার, ইফেক্টিভ মানে হচ্ছে আউটপুট যেটা পাচ্ছ তুমি সেটা।
এমনি বুঝতে পারি, বাট যখন করতে যাই না তখন।
তোমরা একটা কাজ করো, ক্রিয়েটিভ সলভ করো। তো ক্রিয়েটিভ সলভ করার পরে আমাকে ডাউটগুলো বলি যে স্যার এইগুলো পারিনি। ঠিক আছে, তো আমি ওই প্রবলেমের জন্য আমি বুঝবো যে মানে এইটা আমাদের এই টাইপের ডাউট হয়। তো এখন ইন জেনারেল ডিসকাস করে তোমরা বুঝবা না। যখন একটা ক্রিয়েটিভের জন্য আমি বলবো যে এইরকম সিচুয়েশন থাকলে এইভাবে করতে হবে, তখন তোমাদের কাছে ক্লিয়ার হয়ে যাবে ইনশাআল্লাহ। ওকে,
হ্যাঁ স্যার,
ইনশাআল্লাহ। তো তাইলে ঠিক আছে, তোমরা সলভ করো। আমার মনে হয় দুইটা চ্যাপ্টার তো সলভ করতে মোটামুটি টাইম লাগবে। তো থার্সডে এর আগে করার চেষ্টা করো ইনশাআল্লাহ। থার্সডে we will discuss about that. Okay, in between inshallah we will try to progress in higher math. Okay,
yes sir.
okay, so see you tomorrow inshallah. Assalamu alaikum warahmatullahi wabarakatuh.